All right. So we often talk about things as being soluble or insoluble. Solubility is a measure of how much your component will dissolve. So a measure of how much blank will dissolve in blank. This is oftentimes measured in molar solubility. How many moles per liter will dissolve? And you'll touch more on this in Chem 102. For now, we'll just talk about things as being soluble or insoluble. When you start dissolving something into a solvent, you first start off as kind of an unsaturated solution. And unsaturated solutions means that your max solubility is not reached, so you can dissolve more. Right? If you just put a little bit of salt in some water, you can dissolve more, so your salt water is not yet saturated. Then after a while, you become saturated. Even if you add more salt, it won't dissolve. And so at this point, your max solubility has been reached. And you can no longer dissolve anymore. But you can actually overcome this saturated solution, and you can become what's known as a supersaturated solution. And a supersaturated solution is when you're beyond the max solubility. So you've dissolved more than your solvent should be able to dissolve. And you might be asking yourself, how can you go beyond the max? Is it really a max if you're, beyond it? And that has to do with equilibrium. Similar to our gases, the dissolution recrystallization process is an equilibrium. So if if you're in a saturated solution and you've got a block of salt down at the bottom, some of that salt is dissolving, some of it is precipitating out, but overall it looks like nothing is happening because you're at equilibrium. But when you have a super saturated solution, what you do is you have some kind of saturated solution, and then you add some more of your solid. And obviously it doesn't dissolve, but then you can heat it up. So that little triangle means heat. And when you heat a solid inside a liquid, the solubility will increase generally. There are some solids that become less soluble at higher temperatures, but they're more the exception, not the rule. And then if you slowly cool this saturated solution, when it gets down to a lower temperature, it can't hold all of that solvent or all that solute, but it'll take a while for that solute to come out if you don't disturb it. And so it'll actually stay supersaturated for quite a good bit. So when you have these kind of supersaturated solutions, the reason that they're allowed is because they're not at equilibrium yet. And they will precipitate out eventually. You can search on YouTube videos like supersaturated solutions, and you can find some pretty cool ones where they have this clear solution. It looks like nothing's in there. Then they disturb it a little bit, and then you see a whole bunch of precipitate come out. Looks really cool. Definitely recommend you YouTube that. This is also used as in recrystallization. So that's a technique used to purify compounds. And it takes advantage of the fact that hot solvents will dissolve more of your compound than cool solvents were. I think in Chem 102, we'll do a recrystallization. And if you ever take organic chemistry, it's a big topic in organic chemistry. And again, most solids become more soluble when you heat your solvent.